Welcome back. In the same chapter which we are talking about square of numbers, block 12 of class 8. Now we are going to discuss some patterns, right? You had solving puzzles from since your childhood, right? They are based on some patterns. Let's see some numerical patterns over here and we are going to try to extend that pattern for further use, right? 3 square is 9. And how can I write 9 in another way? 4 plus 5, right? 3 ka square 9 can be written as 4 plus 5, the sum of two consecutive numbers. Similarly, 5 square is 25 and can be written as 12 plus 13. Right? 12 plus 13 again are two consecutive numbers which comes next to each other. Now I have to find for the 7 ka square. 7 square 49. Which two consecutive numbers I can write so that their sum will add up to 49? Just think about it. (24) and 25. How I did this? 49 plus 1 50. 50 ka half 25. 25 and 24. 25 plus 1 26. 26 ka half is 13. 13 and 12. Similarly do for 9. 9 ka square 81. Right? 9 ka square 81. The two consecutive numbers will be 40 and 41. Right? 40 and 41. So this is how we are going to extend that pattern endlessly. Right? What we have to do, we have to write the square numbers and then we have to find out which two consecutive numbers can represent that square number. Pattern B. 11 multiplied by 13. Two odd numbers are going to multiply with each other. The answer is 143. How we got the answer? Can I write 11 as 12 minus 1? Yes, of course. Can I write 13 as 12 plus 1? Yes, for sure. So the answer will be 12 square minus 1. 12 ka square 144 minus 1 143. Right? 13 into 15. What is there in between? 14. 13 can be written as 14 minus 1. 15 can be written as 14 plus 1. 14 minus 1, 14 plus 1. So 14 ka square minus 1. That is 196 minus 1, 195. Right? So this is equals to 195 over here. 29 and 31. What comes in between? The 30. So I write 30 minus 1 and I write 30 plus 1. What will be my answer? 30 minus 1, 30 plus 1 according to the same pattern. If we are talking about 14, then 14 ka square. If you are talking about 30, then 30 ka square. 30 ka square minus 1. 3 ka square we know 9. 110 I can write two zeros, right? Minus 1. That is 899. Answer will be 899. This is how we are going to extend that pattern according to our imagination, according to our analysis, how we observe the pattern. Right? Now the pattern C is 25 ka square is 625. Is there any other method to quickly find the square of the numbers ending up with 5, like 35, 45, 25, 15, 85? Yes, for sure. See, 25. 2 is the initial number. I'll add 1, that is 3. 3 2s are 6 and 5 ka square 25. Suppose 45 I'm talking about. I'll add 1 digit to this. 4 plus 1, 5. 5 4s are 20 and 25. If I'll talk about 35, right? 3 ke baad next number is 4. We'll multiply these two numbers. 4 3s are 12 and 5 ka square 25. So these are the answers. This is how we are doing. Let's give one more example. 75, suppose 75. What will be the next number with 7? That will be 8. I'll multiply 8 and 7 together. 8 7s are 56 and 5 ka square 25 I'll write. So 75 ka square directly will be 5625. Right? Multiply the tens digit. with the number just greater than that number, and then write 25 at the last. This is how we are going to find the patterns. These are the patterns related to the square. Now here comes a Pythagoras theorem. A Pythagoras theorem states that the sum of the squares of two sides of a triangle is always equal to the sum of the square of the third side. See, this is 3, this is 4. If this angle is 90 degree, if it's a right angled triangle, then the Pythagoras theorem is going to apply over here, right? If it's a 90 degree angle. So what will happen? This will call base. This will call perpendicular. And this will be hypotenuse. What Pythagorean statement says? The Pythagorean theorem says the square of base plus the square of perpendicular gives us the square of hypotenuse. Let's check. Square of base will be 4 ka square. Square of perpendicular will be 3 ka square. This value should be equal to the hypotenuse square. Hypotenuse ka square is 5 ka square. Let's check the LHS part and the right hand part. Then we'll compare. 4 ka square 16. 3 ka square 9. 5 ka square 25. Its value is also 25. Its value is also 25. That means ki yes, they are the Pythagorean triplets. They are the Pythagorean triplets. Pythagorean triplet means sum of the squares of two smaller numbers is always equal to the square of the biggest number. Again I am repeating, sum of the squares of the two smaller numbers, 3 ka square and 4 ka square, if you are adding them up, if you are adding their squares, that squares will be add on to the biggest number's square. Then it is said to be a Pythagorean triplet. Right? Then it's said to be a Pythagorean triplet. Is there any way to find out the Pythagorean triplets? Right? If I will tell you to find out two Pythagorean triplets, right? So yes, the three members of Pythagorean triplet are 2m, m square minus 1, m square plus 1. 2m, m square minus 1, m square plus 1. Whatever the value of m we will place, we'll get the Pythagorean triplet. Let here m is equals to 2 or m is equals to 3. Right? I'll write 2. Instead of m, I'll write 3. 2 3 is 6. One number is 6. Instead of m, I'll write 3. Then 3 ka square minus 1. 3 ka square is 9 minus 1, 8. The other member of the Pythagorean triplet is 8. 3 ka square plus 1. 9 plus 1, that is 10. Our Pythagorean triplet is 6, 8 and 10. 6, 8 and 10. Let's check whether they are satisfying the Pythagoras theorem or not. The square of the smaller numbers, 6 ka square, 8 ka square, should be equal to 10 ka square. Let's check. 6 square 36, 8 8s are 64. It's add up to 100. 10 ka square, 10 into 10, 100. So yes, this is satisfying our equation. That means yes, this is a Pythagorean triplet. We can easily found the Pythagorean triplet with this formula 2m, m square minus 1 and m square plus 1. Whatever the value of m you will be placing over here, you will be getting the Pythagorean triplets. Now, if I ask, tell me the Pythagorean triplets where the smallest member of the family is 8. Where the smallest member of that family will be 8. 2m, m square minus 1, m square plus 1. Right? I'll start with 2m. Let 2m is equals to 8 because 8 is the member of Pythagorean triplet and we have to assume that 8 is the smallest member. So let's see what about the other two Pythagorean triplet. If we'll get the numbers which are greater than 8, that's fine. If we'll get the number which is smaller than 8, then we have to do something else. Right? So 2m is equals to 8, m is equals to 4 this time. M is equals to 4. So one number we already have. Other number is m square minus 1. 4 ka square minus 1. 4 4 is 16 minus 1, that is 15. The second number is 15. Third number will be m square plus 1. 4 ka square plus 1. 16 plus 1, that is 17. So yes, 8, 15 and 17. These are the Pythagoras triplet where 8 is the smallest number. 8 is the smallest of these three numbers. What if instead of equating 2m with 8, I would have equated m square minus 1 with 8? What would happen then? See, m square minus 1 is equals to 8. So m square is equals to what? 8 minus 1 goes there, becomes plus 1, 9. M ka square is 9. Which number square is 9? 3. 3 ka square is 9. So m is equals to 3 here. M is equals to 3. The Pythagoras triplet I am writing. M is equals to 3. 6 is the one number. 3 ka square 9 minus 1. 8 is another number. And 9 plus 1, 10. See, this is also forming the same Pythagorean triplet. But 8 is not the smallest one. Here 8 is the member of the Pythagorean triplet, but 8 is not the smallest member. There exists 6 as a smaller. So we will not consider this as our answer. We will consider this one as our answer, right? So 8 should be the member of Pythagorean triplet and 8 should be the smallest member. So this Pythagorean triplet will be our answer, right? If we need to find the square of a fraction, how I am going to find out? Suppose if I have to find the square of 2 by 3, what I'll do? I'll square the numerator separately, I'll square the denominator separately and I'll write the number. 2 ka square 4, 3 ka square 9, 4 by 9 is the square of 2 by 3. Take 4 by 5, the square of 4 by 5. 4 ka square separately as a numerator, 5 ka square separately as a denominator. 4 ka square is 16, 5 ka square 25. So this will be the square of a fraction. For a fraction, when we are calculating the square, we just have to square the numerator and square the denominator and then write again. That's so simple, right? How to find whether 55 is a perfect square number or not? 55 is a perfect square number or not? There is some easiest or easy method, simple method how we are going to find out. We will repeatedly subtract the odd numbers out of it. We will repeatedly subtract the odd numbers. If our result is 0 at end, then yes, for sure that number is a perfect square. Let's check for the perfect square first and then we'll proceed with the 55. Let's check for 25. 25, we know that's a perfect square. That means their remainder should be 0. 25 minus 1, 24. 24 minus 3, because the next odd number is 3. 21. 21 minus 5. What will be the answer? Yes, what will be the answer? Right? 16 minus 7. 9. 9 minus 9, 0. Right? What we have done? 1, 2, 3, 4, 5. In 5 steps, we got answer 0. So 25 is the square of 5. 25 is the square of 5. Similarly, you can do with this 55 number or you can do with some other number. If the remainder is not equal to 0, at last you get the negative result or you have something in common and it's not going ahead, then that number is not said to be a perfect square number. That's all for today. Thank you and have a wonderful day.